Welcome to The Buzz. I'm Christopher Conover. This week, unique ways to recycle plastic in Arizona. Many plastics are notoriously hard to give a second life to. Goods from single-use grocery bags to berry containers are frequently on the list of items that recyclers call wish-cycled goods, products that people put into recycling bins but aren't actually recyclable. But a handful of projects in Arizona are making that wish come true, giving hard-to-recycle plastics a second life. We start today's show with one such company, Bifusion. For years, people have been able to drop off just about any form of plastic at one of the company's collection bins around Tucson. That plastic eventually finds a second life as a construction block. The company's buy blocks can be found at various spots around town. Bifusion's Heidi Kujawa spoke with The Buzz producer, Zach Ziegler.
The former city council member who got this ball rolling, Steve Kozachik, had a planner in front of his office that was built with Bifusion blocks. What kind of projects are these things good for? I mean, if you had enough of them, could you build, a wall or heck, even maybe a house?
Councilman Kozachik has been amazing. He clearly understands the value of what we were bringing. And in fact, a lot of council members did too. Mayor Romero was extremely supportive from day one. And she realizes the value not only in the recycling, but also how the program can touch on a number of areas within the climate action plan that the city is committed to. So, the support from the government leaders in the community has been overwhelmingly positive, and I'm really excited to be able to work with such thought leaders in this space. BuyBlock is designed to be one of the most versatile building materials on the market. It's not a monolithic building material. It's designed to help us reduce our dependency on cement and lumber, but not necessarily replace it, right? We work in conjunction with it. So where the engineers might say, hey, Heidi, please, you might need some extra support here for this roof load, we can add that to the wall. Throughout Tucson, we've developed we've already built a number of different structures, from utility to park applications. There's a 72-foot wall in the Mission Gardens, so you can see that at Mass. It's a beautiful wall. It displays 6 tons of plastic waste, of Tucson's plastic waste from landfill, and it's a gorgeous installation. Yes, we've built houses with BuyBlock already as well, so I'm looking to do some more of that in Tucson. Not in Tucson, but we'll do that in Tucson soon enough.
One advantage to typical cinder blocks is they're cheap. How does a company compete when the product you're competing against is that cheap? I mean, I can imagine that part of the industry isn't too easy to disrupt.
Yeah, it's interesting. The price points when we have this discussion, it's always a fun discussion to have, because everybody thinks of the hollow cement block that's anywhere from $1-ish to $2, depending on the time of the year, to a buy block, which is about $3. What they forget about the cement block is the mortars and the rebar and the labor and the skill required to build with that particular material. Whereas BuyBlock doesn't require all that stuff. You don't need a lot of time to do it. You can stack BuyBlocks and very quickly, and they just screw together. So anyone can build with a BuyBlock, and you need less materials. So when you think about the overarching product or project, you're actually building much cheaper and much faster.
So with Tucson, one thing you always have to worry about when you're building, especially a structure for a house, R values, how good the insulation is. How do these blocks stack up against, your more typical cinder block in our case, keeping the heat out and keeping the conditioned air in?
We've done a lot of testing on thermal properties of BuyBlocks, and the good news is it's actually more insulating than concrete blocks. We get about R value of 8 with a single block, so it provides a nice core starting point for your wall assembly. You can also add additional insulation to BuyBlock, and then you've got your interior, exterior cladding. So when you think about a wall assembly, you can get to your required R values very quickly with less material in the wall as well. The thing that's really interesting, though, that I love about talking about Tucson because of the high sunlight, there's a thermal property called K factor that we don't really talk about too much as in normal conversation when it comes to thermal properties. And K factor is actually that phenomenon of radiating heat back to you. So I'm sure if you walk down the street in the middle of a beautiful Tucson afternoon and you're walking next to a cement wall or a cement building, you can kind of feel that wall next to you radiating some heat back. With BioBlock, it actually, the nature of plastic, it actually dissipates and absorbs that heat. So you don't get that contribution to that urban heat umbrella that you hear about sometimes. So it helps to combat some of that.
What are the plans to scale the operation maybe and make it so that these things are a little more available to the general public if, someone just wants to build a planter in their yard or, wants to build a small retaining wall using these?
The thing that we've been extra conscientious about is it is a building material. And we wanted to make sure that when we opened the availability of the product to the general public, that we had the right kind of tools and resources available to teach people how to properly install it. Because that's one thing that's important when it comes to building materials, right? So we've been really focused over the last couple of years on just working with general contractors because they get it, right? So we've got some much more learnings under our belt. We've got a lot of instructions that we've been working on pulling together so that when we're ready for selling to the general public, we've got those resources available. My goal is right around the groundbreaking of the new facility, we're aiming to have that launched so that people can start consuming some of the product locally.
A lot of Tucsonans have dropped off plastics in the bins where it's being collected for Bifusion. Can you give me a quick version of what happens once that plastic makes its way into your company's hands?
We have a diversion report that I'll make sure we get to your audience so you guys can see how much we've diverted, the tonnage that we've diverted, how much was contamination, and more importantly, where that material went. I'm really proud to share that of the material that we've processed to date, over 50% has already gone back to Tucson into construction projects, which is amazing. The other products have gone to other projects across the country, but Tucson has first priority to their own material. Typically what happens is once the material gets into the roll-off bins are then compressed into bales. They're sent to us. We process those into blocks. We stick those blocks back on a truck and headed to the job site back to Tucson.
You mentioned contamination rates. What is it exactly that can be kind of counted as contaminants? What are the things that people are putting into those bins that maybe they shouldn't be?
So contamination is kind of a weird word. We like to say like maybe incompatible materials. Contamination is an industry word, but the contamination or incompatible materials that we see are anything that's non-plastic, or there's a couple of drop-off locations that are near industrial sites or scrap yards. So oftentimes we'll get a pallet of material that's basically got a half a car in it, or half of a lawnmower, or crazy stuff. You would be surprised about the crazy stuff that we see. But think about it in terms of anything that's non-plastic. Or it's very contaminated with food. Don't send me your moldy loaf of bread. Don't do that. I'll take the bag, but put the moldy bread in the black bin, please. That's the kind of contamination that we see.
Yeah, clear out the stuff on the food that's easy to get out of there.
Yeah.
How far are you having to haul that plastic back and forth? And I've heard there is some talk of that distance getting a little shorter.
Yes. So the distance right now is we're Tucson to LA, which is an 8-hour truck ride, which is not fun for anybody. We are very, very environmentally conscientious. In fact, our process has undergone extensive testing and with transportation and logistics factored in. So of all of the environmental numbers and that we've shared on our website, that is by us collecting material from as far as 1,200 miles away from Los Angeles. Our goal as a company is not to truck material to us. Our goal as a company is to serve local. our goal as a company is to service a 200-mile radius. So when we come to Tucson, we'll be focused on Tucson, and we'll be servicing around that 200-mile radius. It's really where we're focused.
Folks around town have noticed recently that Bifusion asked that plastics start being placed in those orange, hefty Renew bags. Why was that change necessary?
Well, that's a really good question. So there's a couple things going on with that. So Bifusion and Hefty have been working together for years. We literally just celebrated our 4-year anniversary. They're a great company. They're able to capture waste a little bit differently than we are. I mean, they're really focused on helping consumers in the home capture waste, and we're really focused on business to business, and obviously we help consumers too, in partnership with city drop-off programs and things of that nature. Right now, we're in this interim phase. So when we signed up to be a partner with the city on this program, we have to find a home. So the city is building us a building at the Los Reales Sustainability Campus for us to operate our equipment there. That construction project, it's new construction, so it's taking some time for that to come together and the building to be erected. The good news is the plans are done, the contractor's been selected, and right now I think we're aiming to do groundbreaking sometime in the early fall, so we're right around the corner. Between now and then, though, we're collecting a lot of material that we want to make sure that we can process. That transportation interim phase is kind of causing some complications, and we don't want to stop the momentum of the city. So where Hefty's coming in is to help us make sure that stuff stays out of the landfill, and is giving us a couple other avenues to ensure that it's not stockpiled. And that's really what we're focused on. Once we come to the community, then we'll make some of those adjustments. It's very much an interim phase. Hefty will still be there when we come, and they're just really great partners, and they're really enabled us to keep everything moving as we wait for the building and the site to come up.
Well, thank you very much for joining me today, Heidi.
Oh, my pleasure. Thank you for having me. It was really wonderful speaking with you.
That was Heidi Kujawa of Bifusion talking with our producer, Zach Ziegler. You're listening to The Buzz. After the break, we hear about another plastic recycling project in a Phoenix suburb. Stay with us.
New from the Embedded podcast. Female athletes have always needed grit and talent. But for decades, they've also needed a certificate.
There was chit-chat about, is that really a woman?
And even now, they're still being checked and questioned. Their story is the newest series from CBC and NPR's Embedded. It's called Tested. Listen wherever you get your podcasts.
Welcome back to The Buzz. I'm Christopher Conover. We're looking at new efforts to recycle plastic in Arizona this week. The Phoenix suburb of Surprise will soon have its own recycling partnership to brag about. Late last year, it signed a deal with British company Autometi. Autometi will help turn plastic waste into filament for special 3D printers that can be available for residents to use around the city. To learn more about the project, we spoke with Autometi's managing director, Ether Alali. I started by asking him what kind of plastics can go through the process.
The reason why is there's so many different types of plastic, and actually the things you buy in the shops may be made out of different plastics, often by different manufacturers, and sometimes by the same manufacturer at different times when they discover something better about another plastic. But in general, we will take pretty much any plastic anyway, regardless. So whether it's your garden chairs, your beverage cans, or cups, or even carrier bags, we will take. And what we'll often do is blend them together. And there's a deliberate reason for that, because part of our innovation is how we think about plastics as a resource. And that includes how it's formulated. So believe it or not, we use a lot of the same thinking that goes into creating concrete to create the filament, right? So the thin plastics are kind of like the slurry type of concrete, while you have the aggregate, which are often buckets or old garden chairs or things like that. Because often when you grind them, they grind into different I'll put sized flakes, and that can often make it different to extrude it as well. So when you put the softer plastics in, it makes a much better grade of filament that makes the thermal properties much better, and as a result, it makes it extrude better through a 3D printer. So what we do is we take any deficiencies in that material, whatever it will be, and it can include the food that's left in it or whatever else, and actually use it as an advantage by almost over engineering at the manufacturing stage, which, as you know, we use 3D printing for. So by doing that, you get to kind of balance these two worlds of kind of either degrading or defective plastics or contaminated plastics with the manufacturing capability to actually kind of upscale that plastic to ensure you get a good quality product at the end of it. Because at the end of the day, it's the product that matters.
It's interesting. You mentioned a couple of things that we don't necessarily hear a lot about recycling here. Lawn furniture, garden furniture, old buckets. I think when most people think about recycling, they think about what they get at the shops.
Right.
So this is a much larger project than maybe people are used to.
Totally. It's larger in the sense that we recycle a lot more stuff. And back in the day when they started talking about recycling, you probably remember this problem. People didn't know what to put in their bins. It's like, what do I put on my curbside? Is it just the bottles? Can I put my garden furniture in? Can I put my car's old bumper in it? Those are the sort of questions. And the answer was, most of those cases was no. Anything that's shaped by a bottle is like a bottle rather. Anything that's shaped like a bottle is the only thing you can put in that bin. And that's obviously a very restrictive way of doing recycling. And anyway, that stuff only ends up becoming another product less than 1% of the time. Often it gets burnt or it gets dumped in landfill. So we thought the whole system is broke. Let's be honest with you. If you want to do recycling and you're not sure about it, tell you what we'll do. We're going to create a brand new system, closed loop, from scratch, that will allow you to put literally any type of plastic in it. And that was meant to be kind of like the wish cycling dream. That means if you're not sure, give it to us, we'll find a way, is the short answer. So that's basically what we try and do. And that means it is a much bigger project. And some of the solutions we don't know yet because we haven't received every single possible type of product, as you can imagine. So yeah, I don't think we've received anything like kind of dolls' heads yet, or at least dolls' wigs and all things like that. There's a lot of really weird stuff that you kind of get. I mean, the kind of personal items are another thing we've not received yet, hopefully for the better, but that's another story for another day, I'm sure.
Yes, now I'm picturing just this line of doll heads rolling down, for recycling.
Yeah, it feels like Chucky. Yeah, that's right.
That's an image that's going to keep some people up at night, I think. But
I'm so sorry. Yeah, keeps me up at night.
So without getting too technical or spilling any trade secrets, how do you turn plastic into filament? You said it sort of gets ground up and reheated, but walk us through that a little bit.
Yeah, sure, no problem. So what we do is we basically get a load of stuff. And you can imagine the bin of stuff that we get is very diverse. There's a lot of different things in it. Normally what happens is that you'll grind it up, and then at that point you'll float it in a bath of water. But you can imagine that the traditional way of doing that, which is meant to separate out the heavier plastics from the lighter stuff, usually the heavier ones are the valuable PET, the kind of drinks bottles that you get from all the other plastics. The problem with that is that creates more pollution because the water itself is a pollutant, right? So what we try and do is we've developed a process which basically dry sorts it by object size, believe it or not. And the reason why is because when you look at what organizations and companies manufacture, they choose their plastics typically for the size of product that they have. Right? So as a bit of a secret, therefore by sorting it by size, we're able to then effectively get about 70% of the 80% of the sorting process, segmentation process done, because it's basically done by size anyway. So we'll then grind that stuff down, often mix it together as a bit of a recipe with other plastics of the same type, but maybe different grades and certainly different ages. So that allows us to reuse older plastics time and time again. And then we more or less heat it in the normal extrusion way and extrude the filament out of it at that point. Once we've done that, we then spool that into what we're called spools, basically. And those spools are effectively the consumable, refillable parts of the 3D printing process. So we'll often put those in our 3D print vending machines. And those vending machines are located where customers want to buy the product, not where we can put a factory. So that removes all the typical transportation and logistics, vans and lorries typically, that will often move things around from a factory or a warehouse to the retail store. Because you can put these in retail stores, you can even put them in service stations or places like that. So the idea behind it is it removes a lot of the transportation, which is usually the bottleneck in trying to remove emissions from the atmosphere.
We were talking about as you dry sort by sizes and things like that. Are plastics structurally different, and can they all hold up to the same use? And as you said, you haven't found something yet, and maybe someone will put something in.
There's a challenge right there.
Yeah, well, exactly. Somebody listened to this and said, challenge accepted. Are they structurally different? Or once you've processed them, plastic is plastic?
No, so they are structurally different. And that's often why the choices are made at manufacturing level to make the products of this particular size with a particular type of plastic. And it all depends on mechanical performance. So some plastics, you want them to be more rigid and have less flexibility in them. Others, you'll want exactly the opposite. So they choose plastics appropriately, and we do the same. But what we're able to do with 3D printing that you can't normally do with injection molding is you can effectively mold the inside of those plastics in a way that you can't do with, if you like, the void of an injection molded mold. Because by doing it that way, you can create plastics that change shape. You can create plastics that you can fold up. And in fact, some of our larger products are actually made on much smaller format machines because we fold it in 3D space into the little cube that it'll fit into. And then once you're finished, you literally take it off the bed, crack it open, and then unfold it to its full size. And that's how we can do things that other manufacturing processes can't. So you can sort of see that we can start to create overlapping, let's call it, use cases between the plastics that are normally done or used in a particular way under normal manufacturing or conventional manufacturing ranges. And that's one of the benefits for us. So although it's not plastic as plastic, what we're able to do is to overlap the purposes for which that plastic is used.
So when it comes to the filaments, does the recycled filament that you all are working with act differently than the virgin plastic filament?
So sometimes it does, absolutely, and sometimes very deliberately. So one example of what we more or less deliberately engineer filaments like that is we will introduce additives into it for one reason or another. Now, what is an additive? Probably the most obvious one is where you introduce things like carbon fiber or fiberglass into a plastic deliberately for the purpose of strengthening the plastic. Now, we found ways of doing that with the food contaminants that often come with the plastic itself, believe it or not. So one example, or one of the most classic examples that we often have, is where we will take a milk bottle with often, let's just say, overly exposed milk still involved in it. And we'll even use that as a way to strengthen some of the older versions of that plastic within that process. It's very, very unique. We didn't actually expect to do that. We just did it one day and thought, well, what's the worst good that could happen? It removed the smell, which, as you can imagine, was terrible. But it also strengthened the plastic for our purpose. So when we then combined it with the softer film version of the same plastic, we got a really good filament out of it, despite the fact that, well, it was probably 30% cheese by that point. So yes, it's a very interesting sort of approach to kind of look at ways of changing the plastics very deliberately. But there are certainly other cases where structurally the plastics are not the same, even by accident, or at least through generational degradation. And that latter case, what we will deliberately do is over-engineer the product at manufacture so it makes up for the weaknesses in the filament itself.
You mentioned earlier some of the costs of transportation, which now you don't have to worry about.
Yeah.
That's always seemed to be when the consumer wants to buy recycled products, right. Oh, they're more expensive. Does this process keep the price down for the consumer?
100%. And the reason why, believe it or not, is because I'm giving away my trade secrets here. Listen, that's all if anybody else wants to know. We make money on both sides of the connection. We get paid to take waste away, and that subsidizes the cost of the recycling locally when we manufacture the product. So yes, it does keep the price down because it keeps much of that quote unquote supply chain out of the supply chain, but also it makes us money on the waste collection side of that connection, thereby kind of almost each side subsidizes the other. That's why it's often just as cheap as buying virgin plastic products from the shops.
It's interesting. You just mentioned that it's being collected and processed locally. Earlier in the show, we heard about a plastic recycling effort here in Tucson, which is a couple hours south of Surprise, Arizona. And that one requires plastics be sent to Los Angeles.
Yes.
It's a 7-8 hour drive away. It sounds like your plan, nope, it's all right locally. I mean, it might not be next door, but it's pretty close.
Pretty close. I mean, that's the plan. Because as you can imagine, you can buy a product in the shops and the packaging for that product was made thousands of miles away. And then what you'll do is you'll throw that packaging in the waste, and that waste will be taken to, as you say, LA, abroad. And what you've then got is you've got thousands of miles just for, I don't know, a peach cup, really. So you can imagine that that's not a very effective way of using transportation. It's very costly. It requires a lot of licensing, and a lot of things get lost in translation, in transit rather. So, for example, you might end up losing how many people are involved in that post. You might end up losing the emissions because you've decided to export them to another country. You might even have lost the packaging because that packaging might end up on a beach somewhere in a country which doesn't have any waste collection and processing facilities. So there's a lot that can go wrong. So one of the reasons why we try to do that is that, well, listen, you're transporting products from thousands of miles away to wherever you are, and you're throwing waste away only to take it 1,000 miles in the other direction. So you may as well just combine those two bits together and do it locally and actually keep the kind of economic value local as well, for sure.
So this is consumer grade printing, and keeping in mind, that this is a family show, what are people printing with 3D printers?
Yeah, well, listen, we're not going to talk about the other sorts of stuff we might get in our garbage one day, but certainly it could be also. What we find a lot of people do is they end up making stationery. They often do home improvement tools. So the little knickknacks, the kind of fixtures and fittings that you often get, ideal to be used there. You might find people do customized stuff. So we often sell a frame where you get to customize a slot in, and that slot in that you get is actually a picture that we've turned into a 3D printable, almost silhouette. Behind it is an LED lamp that lights up and shows that picture basically to any of the viewers. So that's another thing that people get. We find also, we've got the best part of 700 different products in different catalogs across the piece. So in essence, it's a hardware store in the space of a desktop machine, basically, on the manufacturing side at least.
Well, that all sounds really great. Well, thanks for spending some time with us.
No, it's been a pleasure. Thanks for having me.
That was Automedi's Ether Alali. And that's the buzz for this week. You can find all our episodes online at azpm.org and subscribe to our show wherever you get your podcasts. Just search for The Buzz Arizona. We're also on the NPR app. Zach Ziegler is our producer with production help from Desiree Tucker. Our music is by Enter the Haggis. I'm Christopher Conover. Thanks for listening.
AZPM's original productions are made possible in part by the Community Service Grant from the Corporation for Public Broadcasting and by donations from listeners like you. Learn more at support.azpm.org.